This meeting is being recorded.
This is the androsterone. So this androsterone was first isolated by the scientist named as Buchanan, Butenanddt. So he isolated this hormone in 1931 from the male urine. So, okay.
मैम स्पेलिंग की है BU
Tenandt. Okay. So the molecular formula of this androsterone is C19H30O2. Okay. So this is the molecular formula. So when you calculate its double bond equivalent, so it comes out to be 5. Okay. So from the molecular formula, we will calculate this double bond equivalent using the formula number of carbons minus number of hydrogen by 2 plus 1. Okay. So we will have this. Now, if you do the functional group analysis, so then we carry out functional group analysis. I'm writing it as FGA. So this functional group analysis, so this androsterone forms monoester. So it is forming monoester. So this indicates the presence of one OH group. So this reaction indicates that it has one OH group. Not monoester, sorry, it's monoacetate. If it is ester, then so when we treat it with the acetic acid, then it forms monoester. And if we treat it with the acetic anhydride, then it forms monoacetate. So it is forming monoacetate with the acetic anhydride and monoester with the acetic acid. Okay, so both are correct, and this observation indicate one OH group is present. So next it forms oxime. So this means, and it is forming monoxime. So this indicates one keto group is there. So one keto group is there. Further, so when we do the catalytic reduction, it do not add hydrogen. So this indicates it is a saturated molecule. So it do not add hydrogen atom. So further, if you add bromine also, so it is not added to the androsterone. So this observation also indicates the androsterone is a saturated ring system. It does not contain any double bond. Okay. So further, it is found to be a tetracyclic molecule resembling the cholesterol. So this means it has steroidal nucleus. So the presence of steroidal nucleus is also confirmed by the formation of dies hydrocarbon. So this androsterone forms dies hydrocarbon. So when we heat this androsterone with the selenium and in the presence of the selenium catalyst, androsterone gives dies hydrocarbon. So this again confirms the presence of steroidal nucleus. So steroidal nucleus का मतलब होया double bond equivalent equals to 4. So 4 from the steroidal nucleus. But you have calculated that it is having 5 double bond equivalents. So 4 is for cyclic ring. It is tetracyclic molecule. So one, that means there is one additional double bond equivalent. So this one additional double bond equivalent will come from the keto part. Okay. So you have already confirmed that it is having one keto group. So this one keto account for the another double bond. So if you add these cyclic ring and keto, so it will make total of 5 double bond equivalent in androsterone. So on the basis of these observations, so what was found that this androsterone, the structure of androsterone is so it is a tetracyclic ring system, spheroidal nucleus. Two 6-member rings are there, and the keto group is there, angular methyl, again angular methyl, and here we are placing like cholesterol right here. So this is the structure of androsterone proposed. Okay. Hello.
हाँ जी मैम.
Yes,
Okay.
ma'am.
So that structure of androsterone and is then confirmed by the scientist named as Buzicki. So he has confirmed this structure of androsterone. What he has done, he has taken a molecule named as 5-alpha cholestynyl 5-alpha cholestynyl P-beta acetate. So he has taken this molecule. So let me draw its structure. So here is H, acetate instead of H. So we have acetate group, and moreover, here instead of ketone, so he has taken the acetate of cholesterol. And what he has done, कोलेस्ट्रोल दी एसीटेट ले ली जिन्हों ਅਸੀਂ कह रहे हैं 5 alpha cholestynyl 3 beta acetate. So this is the complete name. So what he has done, he oxidized this molecule with chromium trioxide. So chromium trioxide, and then he did the hydrolysis. So when he oxidized it, so he got a keto group at this position. Okay. So और कीटो आ जाएगा, ठीक है. So and OH here by
मैम
हाँ जी.
मैम अगर ਆਪਾਂ ਐਸੀਟੇਟ ਲੈ ਰਹੇ ਕੋਲੇਸਟ੍ਰੋਲ ਦਾ ਦੈਨ ਡਬਲ ਬੌਂਡ ਨਹੀਂ ਆਊਗਾ ਵਿੱਚ
Yes, it should be there. So he has reduced this cholesterol ਦਾ acetate ਲੈ ਕੇ ਉਹਦੀ reduction ਕੀਤੀ ਹੋਈ ਹੈ ਤੇ ਇਹ molecule ਬਣਿਆ cholestynyl cholestyne ਲਈ ਹੈ ਨਾ 5 alpha. I have told you wrongly. वो double bond नहीं आएगा, वो भी reduced है 5 alpha cholestynyl 3 beta acetate. ठीक है. 5 alpha ਦਾ ਮਤਲਬ ਹੋਇਆ ਕਿ alpha ਹਾਈਡਰੋਜਨ ਹੈ, ਇਸ ਕਰਕੇ ਤੇ 3 beta ਜਿਹੜਾ ਹੈ ਇਹ ਹਾਈਡਰੋਜਨ ਰਿਡਕਸ਼ਨ ਨਾਲ ਹੀ ਆਇਆ ਹੋਏਗਾ ਡਬਲ ਬੌਂਡ ਦੀ. ठीक है. So this stereochemistry arises from the reduction of cholesterol. So 5 alpha ਤਾਂ ਹੀ ਲਿਖਿਆ ਹੈ and then 3 beta acetate. ठीक है? So he has taken acetate of cholesterol and then reduced it. ਤੇ ਉਹ ਜਿਹੜਾ product ਆਇਆ then he has used for the further reaction. Okay. So
Yes,
please
ma'am.
put at C17 this keto group because I am not able to put it here. मैंने छोटा करना पड़ेगा. So yeah, going to be. So here we will have a keto group at this position. So after this, so he got this molecule. So this is known as, so now if you compare with the androsterone structure, so androsterone the case ਚ OH ਇੱਥੇ ਹੀ ਸੀਗਾ and a keto ਸੀਗਾ. So this resembles the androsterone, but it is not androsterone. So he has written it as epiandrosterone. Okay, so epiandrosterone. लिख लो फिर दूसरी स्ट्रक्चर फिर बनाने हैं. Epiandrosterone. Okay. Then what he has done, then he has taken the 5 alpha cholesterol, now 3 alpha acetate. So there is difference of stereochemistry actually. So here it should be like this, and in the other one it is reverse. So he has now taken. So there is mistake in book. Please note down. कि ਜਿਹੜੀ acetate ਦੀ stereochemistry है ना, that should be reverse in this case. So here he has taken 3 beta. Beta मतलब ਹੁੰਦਾ है पिछे point out करना. Book strong बनाया है, so it should be wedge. ठीक है? ਹੁਣ ਜਦੋਂ ਤੁਸੀਂ ਦੂਸਰਾ ਲਓਗੇ 5 alpha cholesterol 3 alpha acetate, ਉਸ ਕੇਸ ਚ acetate ਅੱਗੇ ਨੂੰ point out ਕਰੇਗਾ. Am I clear?
Yes, ma'am.
ਸੋ ਪਹਿਲੇ ਤੁਸੀਂ ਇਹ ਵਾਲਾ ਬਣਾ ਲਓ ਐਂਡ ਆਫਟਰ ਦੈਟ ਉਹ ਜਿਹੜਾ ਤੁਸੀਂ ਪਿੱਛੇ ਬਣਾਇਆ ਸੀਗਾ ਉਹ ਦੁਬਾਰਾ ਬਣਾਓ and then write down chromium trioxide and hydrolysis. In that case you will get androsterone as a product. Stereochemistry ਜਿਹੜੀ ਹੈ ਸਹੀ ਆਏਗੀ. ਠੀਕ ਹੈ? So from this reaction he has confirmed that कि ਜਿਹੜਾ hydroxyl ਦੀ configuration है that is beta in case of androsterone. So it is alpha in case of androsterone, not the beta one. ठीक है? तो stereochemistry confirm ਕਰਨ ਵਾਸਤੇ ਇਹ reaction ਕੀਤਾ ਸੀਗਾ. मैं again थोड़ा ਜਿਹਾ repeat करदी ਹਾਂ ਇਹਨੂੰ. So what he has done, he has taken the 2 different isomers of cholesterol. So ਇੱਕ ਜਿਹੜਾ acetate ਹੈ ਉਹ alpha ਹੈ, that is 5 cholesterol 3 alpha acetate. So ਜਦੋਂ ਅਸੀਂ alpha ਵਾਲਾ ਲੈਨੇ ਆ 5 alpha cholesterol 5 position ਤੇ same ਲੈ ਲਈ stereochemistry 3 ਤੇ change ਕਰਤੀ 3 ਤੇ acetate ਲੱਗਾ ਹੋਇਆ ਨਾ ਉੱਥੇ alpha ਤੇ beta ਇੱਕ front ਚ point out ਕਰ ਰਿਹਾ ਇੱਕ back ਜਿਹੜਾ front ਚ point out ਕਰ ਰਿਹਾ that is beta ਤੇ ਜਿਹੜਾ back point out ਕਰ ਰਿਹਾ wedge ਤੇ ਉਹ alpha ਹੈ ਤੇ ਜਦੋਂ ਅਸੀਂ ਇਹਦੀ ਕਰਦੇ ਹਾਂ we get androsterone. So we get a molecule whose properties are exactly matching with the compound which we have isolated from the natural source. Okay? So that is androsterone. Whereas in the other case, ਜਦੋਂ ਅਸੀਂ 5 beta cholesterol 3 beta acetate ਲੈਂਦੇ ਆ, in that case we get another molecule which we call as epiandrosterone. So the properties of this is not matching with the compound isolated from the natural sources. Okay? So this is all about the structural information of this androsterone. So baki hun, so we will do after MST. Okay, so I will stop here. Is there any question?
मैम
हाँ जी, एक मिनट, जस्ट
मैम इन्हें स्ट्रक्चर्स एक बार दस दोगे?
जस्ट अ मिनट बेटा.